Hey, welcome to another episode of I Can Alteryx That with coaches Alex and John. I'm John. Today, we're going to cover Alteryx Weekly Challenge number 214. Let's get started. Alright, so we've got Challenge 214 here, U.S. military and high points. And the instructions are, the MIRTA dataset contains geographic information for major military installations, blah, blah, blah. Okay, let's look at this data. Alright, so we got just basic information and a spatial object. So nothing really special there. Everything looks perfectly fine. And the other data set is a listing of the highest elevation peaks in each U.S. state. It's kind of funny. I've used the high points per state data a lot in the trainings that I've made. But obviously here we're going to have to do something with this. We've got one column. It says one dot and then the state name. We've got the highest peak, the elevation, and the coordinates. And then that's repeated for each state. So we got 200 records. 50 times 4 gives us the 200. So we have three goals. Which peak ranks number 14 when only considering the highest peak in each state? So basically we want to find the 14th highest high point. Then which high peak is closest to one of these MIRTA sites? Then finally, how many high peaks are closest to a MIRTA site that is in a different state? We can see here we have our three answers. So I think the first thing I want to do is reshape this data. That's going to be the real challenge here. So to do that, the first thing I want to do is write a regular expression. And what I want to do is just to identify the fields that start with a 1 dot or 2 dot. So to do that, I think what I'm going to do is write this regular expression right here. So in parentheses, we have \d, then in squiggly braces, 1, 2. So that's either a 1 or 2 digit decimal or number. I should say 1 or 2 number characters, followed by the period. And we have to escape the period with a slash because period has a special meaning in regular expressions. And then I'll just do the lazy match after that. And we will do the match method. So this is just looking to see, does the string match that pattern at all? Alright, so you can see right there we've got a true on Alabama, a false on the next three, a true on Alaska, false, and that looks good. So the next thing I think I want to do is create an ID field. And it's going to go 1, 1, 1, 1, 2, 2, 2, 2, and so on. So it'll be a state ID field. So we'll use a multi-row formula. Just call this ID, and this will be if. So if the previous row, no, if the current row, so field 1 matched. So if our current row equals 1, so that means if it is a match, then we're going to do row minus 1 of ID plus 1. So we're going to increment that ID field. Otherwise, we'll just keep it the same. And that should be the trick right there. Ah, perfect. 1, 1, 1, 1, 2, 2, 2, 2, and then scrolling down all the way down to 50. So that looks good. So the next thing that I want to do is, looking at field 1 here, we can see that these other three have like a column header, highest peak, colon, elevation above sea level, colon, coordinates, colon. So let's go ahead and use text to columns. And let's split this by the colon delimiter. And this won't be perfect because we know that first row, like the state doesn't have a colon. And you can see here, in those cases, because there's no colon, the 1 dot Alabama is in the first column and nothing's in the second. So I think what I'll do now is let's grab a formula tool. And we're just going to fix that. So we'll change column 2 and we'll say if is null of column 2. So if that's null, then we want to replace it with column 1 because what I want to do is basically I want this column 1 to be my column headers and I want column 2 to be the values. So what I want to say is when 2 is null, give me Alabama. And then we'll be able to replace column 1 and we'll call it like state or something like that. So if 2 is null, then we'll just use column 1. Otherwise, we'll use column 2. And then we'll go down here and we're going to change column 1. Again, now we're going to say if, because I can't say if 2 is null anymore because we just replaced it. So we'll go back to our field 1 matched. And really, I could have done this early in the first step as well, but it doesn't matter now. So if that is 1, i.e. if that is true, then we'll call this state. Otherwise, we'll just leave it alone. And that should be pretty good there. Yeah, so you see here now in column 1, we've got state, highest peak, elevation, coordinate, state, highest peak, and so on. And then column 2 has our field values. Is there anything else that we want to do in there? I don't think so. So let's go ahead and reshape our data. So we'll use a crosstab tool. So now with the ID field and those 2 new fields that we created, this should be pretty easy. We'll group by ID. Our column headers comes from 1, and the values comes from 2. And because it shouldn't actually make any difference what we choose here, because there's only 1 record per column header per ID, I'll just go ahead and click on first. But really, it shouldn't make any difference. Hey, 50 records. That's exactly what I wanted to see. So we've got 1 record per ID. We've got our coordinates, which still need work, elevation, which still needs work, highest peak, which still needs work, and then our state field, which also still needs work. So let's just go ahead and, again, this is probably not the most elegant way of doing all this, but it's what's coming to mind first, so we'll stick with it. So let's go ahead and clean the coordinates field. No, sorry, elevation of sea level field. We'll get rid of the comma, we'll get rid of the everything that's not a number, basically. So let's deselect everything here other than coordinates. We'll leave that, we'll get rid of letters, we'll get rid of punctuation. And when we run this, coordinates should look good. Oh, crap. Not coordinates, elevation above sea level. Sorry about that. We definitely don't want to do that to coordinates. And now we can see elevation is good. So now what I'm going to do is use this one more data cleansing. And we'll just get rid of all the white space from everything. So we shouldn't see any more error columns here. So highest peak column is good. Elevation column is good. State, I still want to get rid of this number. And coordinates, I want to work on that. So what I need to do now is split coordinates into 2 separate columns. So go to the parse, grab a text to columns. We're going to split coordinates on a comma into 2 columns. Run it again. So now you see we have coordinates 1, which is our latitude, and coordinates 2, which is our longitude. So we will go ahead and let's grab another formula. And we're going to work on first coordinates 1. So what I want to do here is get rid of everything that's not a number or a period. And to do that, we will rely on our good old RegEx replace. Our string is coordinates 1. So our pattern here is going to be, we're going to make a capture, or not a capture group, we're just going to, a set. We're going to identify a set. What we want to do is say, we only want numbers 0 through 9 and periods. Oh, forgot my backslash. All right. Oh, so actually what we want to do is replace everything that is not. So this caret right here says, things that are not in the set of numbers 0 through 9 or periods, we're replacing them with nothing. And you can see in the data preview that 33.5 with the space degrees north is now just 33.5. Now we're going to do the same exact thing for coordinates 2 with one really important consideration. These are these are degrees west. Typically, when we talk about decimal degrees, west is given a negative number. And if you don't take care of this, you're going to see you have a bunch of points in China. I actually have made that mistake before. So we're just going to concatenate a negative there. Now you can see 85.5 degrees west is now negative 85.8. And finally, let's do a very similar thing for the state. The only difference here, of course, we're going to do this to the state field. We're going to get rid of this caret. So that's going to replace everything that is a period or a number and get rid of it. So it's the exact opposite of what we did for the coordinates fields. We'll run that. Now you can, oh, and let's go ahead and trim. Let's wrap a trim around state as well. Okay, so running this, you see now we have our state, no numbers, no spaces, and then our latitude and longitude fields. So now let's go ahead and create points based on our coordinates fields. I don't feel like renaming them, but we know the coordinates is 2 is longitude and coordinates 1 is latitude. If we run that, we can now see a map of our state high points. Let's just do that for fun real quick. And while we're waiting, I actually have as a goal to hit all of these state high points, so I know for a fact that these are all correct, and I've been to 18 of them myself. But in any case, we can now go ahead and answer question number 1. We want the 14th highest. Oh, actually, let's grab a select tool. We want to make sure elevation is a double, and we don't need to worry about coordinates anymore since we already created that. So that we'll go ahead and sort elevation in descending order, and we'll use the select records to select our 14th state. And we see Guadalupe Peak in Texas at 8,749 feet is the 14th highest state point, which matches our answer. And if any of you are ever in Guadalupe Mountains National Park, I highly recommend that hike. So now let's go on and let's get rid of all this other stuff that's in the way. What we want to do now is identify which of these state high points is closest to a MURTA site. And actually, I think we want to, yeah, it says filter for active MURTA sites. So we'll go ahead and apply that filter. And what field do we want? It looks like operstat equals active. Okay, and I'll just connect a browse to that. So there's a couple ways we could go about this. We want to find which of these state high points is closest to any of these records. And there is a spatial tool called Find Nearest, but I'm looking ahead and I'm saying how many high peaks are closest. So it looks like we want to have the distance from every state high point to every MURTA site. So rather than using the Find Nearest tool, what I'm going to do is actually append records, or use the append fields tool. And I'm just going to combine everything. It's going to make the data set really big, but you know, whatever. What's happening here? And when we do this, make sure we set allow all appends. So now we're going to have, oh, whoops. I don't want to do it to this from the select records. I need to connect it from prior to the select records. So now we're going to have 50 records times 753 records, which gives us 37,650 records in here. But the good thing is we can now calculate the distance between all of the sites and all of the high points. So go to spatial, grab a distance tool. It's already got our two spatial objects there. It's in miles, although that it doesn't really matter. It could be in kilometers, it could be in inches or light years. And we have our distance miles. So we can see our second question asks, which high peak is closest? So to answer that second question, we'll grab another sort tool. We'll sort by distance in ascending order. And we will grab, I'll use the select records, the first record. And when we do this, hopefully we see we've got highest peak Mauna Kea in Hawaii on the Big Island. And that matches the answer. Alright, cool. So that's 2 down, 1 to go. So now we want to find how many high peaks are closest to a murder site in a neighboring state. So I think to do that, what I want to do is go back here to this distance tool. And I'm going to use another sort. What am I doing? I'm blind. So I'm going to sort here by highest peak name and then by distance in ascending order. And let's run this and then I'll explain why I want to do that. So going back to the question, it's saying how many high peaks are closest to a murder site in a neighboring state. So what I want to do is for each high point, I want to find the closest murder site, which is why I sorted first by high peak and then by distance miles. So you can see here, where are we at? So for the high peak Black Elk Peak in South Dakota, I'm now sorting by the closest murder site within Black Elk Peak. And then the closest murder site, Jesus, a lot of these, within Brasstown Ball, Georgia, and so on. So then what I'm going to do is use the sample tool this time. And I'm going to sample the one, so the first n, where n is 1, grouping by highest peak. So this should give me a data set with 50 records. Yep. And so now you can see we have 1 record for Black Elk Peak, 1 record for Black Mesa, then Black Mountain, and so on. And so now we want to find where it's in a different state. So all we have to do, pardon me, is filter where our 2 state fields, state ter, is not equal to state. And this should... Alright, now we have 30 records, and we can see here the answer is 30. So to just get that number, we will grab a count records tool, and that will be the final solution to Alteryx Weekly Challenge 214. That was a lot of steps. That took a long time, but we now have answers for question 1. Guadalupe Peak is the 14th highest state high point. Mauna Kea in Hawaii is the closest state high point to a murder site. And there are 30 state high points whose closest murder site is in a different state. Well, there we go. That was a very long video, but thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemery_dataviz. Thanks again.